Welcome to day 17 of Advent of Code. I'll be solving it live in Liquid Haskell. I got just a minute to go yet. Switch over to my screen share. I did manage to solve part 2 of yesterday's problem. My solution was not particularly good. It took about 38 minutes to run both parts. I didn't make any major changes. Oops. I improved my upper bound a little bit. I had mentioned on stream that I'd assumed we could get a valve opened every turn, and the best case is actually every 2 turns. But I'm not sure how much impact that had. Uh, I generalized the branch and bound to take a move generator function, which just returns a list of possible next search states. And I did manage to solve the termination. What seemed to fix it was moving from the measure that had been defined on the struct, time remaining, to a measure I defined and explicitly gave the type nat to prove it was greater than or equal to 0. I'm not sure that's what was going on, but it seemed like what it wasn't able to prove is that the metric was bounded at 0, and this tells it that it is. So let's look at what we've, but that was a beast. It was my best rank for part 1. It was a pretty good rank for part 2, although I think only about 1,000 more people have solved it since I submitted my solution earlier this evening. So let's see whether we've got another butt buster here. Still hanging out with the elephants. Oh God, are we playing Tetris? Okay. Just gonna pull out our simulation code again, I think. Okay, I want to know how tall the tower will get after 2022 rocks have stopped, but before the 23rd rock begins falling. All right. There's our puzzle input. Fortunately, parsing will be easy today. All right. Okay, I was working on something else there. All right. So where each rock appears that its left edge is 2 units away from the left wall, and its bottom edge is 3 units above the highest rock in the floor. All right. So to that so that suggests to me that we use the lower left-hand corner of each shape as an anchor for what is its position. And I think I'm going to use a map to track all the positions again. All right, so great. Um, all right, let's draw our game board as a record. I am thinking of this as Tetris, obviously. So I'm very tempted to use an infinite list for the wind. We can just repeat the input. Cycle it around. There's a Haskell function to do that. Let's grab our coordinate definition from an earlier day. All right. We're doing x comma y today, I guess. All right. So now we're going to find a piece. So which piece is currently falling? Where is it? All right. So we need to track all the squares that are already filled. So it doesn't even need to be a map. It could be a set. Is there any reason not to make it a set? I don't think so. All right, so there's a set of coordinates. So we're going to have to check the walls and the coordinates to see, when we shove things over or when we drop it, would that intersect with something? All right. And we need the coordinate of the uppermost rock. I mean, we could rederive that every time, but that would be horribly inefficient. All right. So I'm going to give the pieces. Okay, so one option is give the pieces names and write the function in terms of that. The other is define them as sets. I kind of like the idea of just using them as sets. Sure. Uh, I'm gonna. We might want to come in and store some extra state about our definitions. So I'm like we could store their width, but what I'm planning to do is use the fact that they're both sets, so I can offset a piece by a coordinate by just mapping all the locations, and they're all only like 4 or 5 of them, so uh, should be fine, I think. So let's define our pieces. Let's copy these definitions into our specification. Can we say, what's going on here? Can we say anything more specific? Okay, so I guess we need the number of rocks, 2. We're gonna need to track how many we've done. Okay, so All right. We can put a bound on the coordinate. I don't think there's a lot of point to doing that, particularly if we want to be able to remap it. So I'm just gonna call them 1 through 5. Piece 1 is set dot from list of okay. Let's get the pictures up. I guess this is unnecessary. I could just look back and forth. All right. 0, 0. We're doing X first today. So that is 1, 2, 3. All right. All right, piece 2. So that is 1, 0. And then oh, can I use our coordinate? Right then, it's going to be 0, 1, 0, 2. Oh, no, oh. 1, 1, 2, 1, and then 1, 2. All right, there's our X shape, our plus shape. All right, this is gonna be like that, and then go upwards. So 2, 1, and 2, 2. This is just rotated. And then a square. All right, what's it unhappy about? Oh. There we go. All right, so rotation is a bad word here. Piece order. It's time to look up what that infinite list construction function is. Make this big again. infinite lists. Cycle. Do we need to... There we go. So now a nice infinite list tells us which piece is coming next. So let's translate pieces. So we're going to do a... I just have set open. No, I had sort open. So I'm going to do a map. I wonder what it would take to make plus work on our coordinates. Is that even possible? Have to create an instance of num class. What do we need? That's not a complete solution. Oh, we need multiplication. Yuck. An absolute value. All right, it's not a number. So it's not plus. What is it? I could make it a funny plus. Can I make all right, so to translate, we do a set dot map. Oops, there it is, set dot map. And we give it add C to the piece. All right. Oh, all right. This needs to be rocks of P, and we need to wrap it in the constructor. All right, great. That wasn't too bad. So given a translated piece, we're gonna have to check. All right. So given a right, we're gonna have an operation we want to do. We want to blow it or we want to drop it. And before we do that, we want to check if it intersects with the walls or the bottom or an existing piece. So let's write the function that does that. It would uh tell you what, I'm gonna do both the translation and the checking here. Okay, so I'm going to translate it. Uh, so we're going to say floor or wall or existing. So it's floor if any of the translated pieces are at, is it going to be 1 or 0? It's a really good opportunity to introduce a bug here. Which is going to be more useful? Tower of Rocks. So this should be 1. This should be coordinate 1 so that we start with top rocks equals the max height is 0. As soon as we do this, the max height is 1. So the floor is 0. So can we... So we could filter a set and check if it's empty. Or we could generate a set and check if the intersection is empty. But I think empty. Sorry, it's not called empty. It's called null. I think this is our best bet. I don't really want is subset. I mean, disjoint could be useful. Oh, a big O of m log n plus 1 over m plus 1 time. Wow. Uh, that's the same as intersection. Okay. So it intersects the floor if uh, map.filter translated. Did I get the right order? Filter. Predicate first. Y less than or equal to 0. Set.filter. Okay. Not null. Okay. So the wall, let's do the wall in two pieces since they have to either way. So the wall's gonna be at position, left wall is gonna be at position 0 for, why don't you like that? Oh, I should write a higher level function instead of copying this 4 times, but so it is 7 units wide. So this is 0, 1, 2, 3, 4, 5, 6, 7, and then 8. All right. That I gave it as pairs, but our coordinates aren't chords, they're points. Okay. Set dot. Let's use the fancy disjoint function. Filled on the board. Okay. Is that So because I chose to use set, we do have some ability to do refinement types and have them checked. Could we write a specification for this? I'm not sure what it would be. Which means there's probably a bug here, and once I find the bug, then I'll say, "Oh, of course, we should have checked so and so." I'm coming up empty. So let's keep going. I'm going to change this to numrocks remaining. So one step of our simulation, three things have to happen. We have to, okay, so if I'm thinking about how to get started. Do we want to start with a falling piece in position, or do we want to fill it in? I think it's easiest if we this is a good definition for some states, but not other functions we might want to write. Like, uh, how do we tell the difference between when we need to pull off the next piece and when we do not? Let's try to do this, but I might want to make these maybes, but that just makes everything more painful. And this might be the wrong granularity, right? We might want to do it, have a function that iterates over all pieces, and then a function below that that iterates over dropping a rock. Yeah, let's do it piece by piece. Let's do drop a piece. All right, so this is just gonna take the falling piece we've identified, drop it downwards. So we can't all right, so first the wind blow. So it appears first push, then fall. So reading from inside out, first we push a piece, then we fall, and then we check whether to iterate. Okay, so if done, then return what we got. Else. All right. It's fairly high level. We're going to need to prove to it that it terminates, which we can't do until we write these other functions. So and so that's when we'll start writing some specifications, I'm pretty sure. Okay. All right, so let okay, so when we take head wants to know that this list is non-empty, which it is. So in previous days, we've just done a hack of sort of we told it, hey, this is a list that is at least 1,000,000 elements long. Um, I don't know how to write that assumption into place here. Let's think about that. All right. So maybe the head of the list of wins is either going to be left or right. All right, so and these are going to move things either +1 or -1. All right, so we're going to take, so if intersects game piece game the current falling piece of G. That's sort of obvious. Maybe we should write intersects that way. I think we're going to be doing this a lot, but and then the coordinates we need to check are the fallen position of G, add amount comma 0. So add it to the X. All right. So if it would intersect, can't do anything. Oh, no, no. Whatever we do, all right. Whatever we do, we'd better set the wind to the tail. There we go. So, I don't like the name. Other, if it doesn't intersect, then we can move the piece. So the piece's falling position equals the one we just calculated. So new position equals crud. All right. So the new falling position is the new position. Great. So drop piece. It's going to do the same thing. Except it's going to return whether we stopped or not. So we're going to move y by 1. I'm just going to copy the same. Oh, not fall. All right, somewhere Liquid Haskell's got to be screaming its head off, but I've been getting ahead of it. So if our new position would intersect either the floor or another piece or the walls, which can't happen, but I could have wrote 2 intersects functions, I guess. So either we intersect and we're done falling, or this is backwards. We're gonna move -1. All right. Let's check in with Liquid Haskell. I'm sure it. It's probably hung up on the termination error. So we can now. What am I doing? All right. My little library experiment is causing a problem. THC panic. All right. I'm gonna investigate that later. All right. I keep using pairs as coordinates, but they're not. Okay. What else are you unhappy with? Tail. Okay. Coordinate. All right. So there's our termination error. So I think this should be easy because the game board either. Wow. What is going on there? Um, I think it gave me a bunch of types that are all false. Um, all right, so the termination condition is that the piece is getting closer to the floor, or we're done. So whenever we call drop piece again, we must have moved the piece downwards. So I think all we have to do is tell Liquid Haskell that, and then update the fall method to guarantee that. And I think maybe put in a specification for blow piece to say it leaves it unchanged. So this says the y coordinate of the falling position of G is decreasing. I get the wrong slash? Okay. So I can't prove that yet, I'm pretty sure. Yep. All right. It's also giving us crap about taking the head and tail of our infinite list. So all right, so what I'm tempted to do with these infinite lists is create custom head and tail that just assert that they do the right thing. Um, I don't know if I could create a measure on lists that says that they're infinite. Let's give that a try. We're not going to be winning any awards for finishing soon, so let's let's define a all right. All right, so let's define a uh, let's define a Boolean measure that doesn't have a definition. And then we'll write a type for cycle that uh, yeah, we're going to define our own cycle that calls data.list cycle. So we're going to assume cycle from list to list, but the new list will be an infinite list. Okay. Okay, so we let me go look at says it's already got a type. Its type is, I don't know what lazy means in this situation. Spec reference. Is it mentioned here? Disables termination checking. I see. So I'm going to. All right. So sure, we can match. We can match the type. Uh, so this is a list, a non-empty list. Then x greater than 0. I'm pretty sure it is greater than 0. Oh, yeah. Per type v such that the length of v is greater than 0, greater than or equal. Why did it? I just told you it was strictly greater than 0. This is a greater than symbol, isn't it? Hmm. Can I write both? Okay, it says assume overwrites the specification. But if we don't have that, then it says, hey, you didn't. All right. Um, this feels like a bug. All right. So, all right. And so now we need new versions of head and tail. And these are just going to. All right. Parse error on input. Oh. That's kind of silly. We could just define them ourselves. And so it's saying, hey, the specification doesn't match. So So what if we instead make this so the length of XS has to be greater than 0, or it has to be an infinite list. Yeah, so it still complains about I think I'm just gonna have to write both these. Uh, I'd like. All right, let's try using those now. Feel like there's got to be a better way to go about this than just ignore the failure. But we can't actually call infinite list because it doesn't have an implementation. All right, so we're going to replace existing calls with all right, so we're going to have to say this is these are both infinite lists. Oh, we didn't export them. Cycle head tail. I don't know if we have to. Oh, no. We gotta fix this with same thing. Should be hidden now. we really have to qualify it? Okay. And Liquid Haskell seemed happy. There we go. So yes, we said both these have to be infinite lists. The only way we know how to create an infinite list right now is by calling cycle, but we did, we will, so it's all good. All right, it doesn't like that we doesn't like that we specified two specifications. All right. Great. We made it happy about head and tail on our infinite lists. As long as we don't have to concatenate anything with them, we'll be fine. So, all right. It does not believe that we decrease the y coordinate, which makes sense because we haven't told it how we do that yet. So push piece preserves the y coordinate. Y coord of falling position G2 G. Go. Do we need to tell it? We might need to add a specification to our add function. Unbound symbol falling pause. You notice our build time has gone up dramatically already. I suspect it may be all this, but there's really nothing to verify there. All right, so it says, how do I know that move X preserves that? I think it's so it knows what new position is. I think it doesn't know what add does because we didn't give that a specification. But we can inline it. Is that going to be enough? Maybe not. Maybe we do have to give it a specification. I'm hoping it can just say, oh, I can unpack the definition, but that's really for proofs. Wow. It did not like inlining that function at all. All right. Let's write the specification. All right. So given a pair of coordinates, then add had better return the sum. So x coord of sum equals x coord of C1 plus x coord of C2. And same for y coordinates. So that's something it should have no trouble verifying, and it should be able to use that to say things are okay here. Where's my, oh, the error is I can't type. Okay, let's see if that moves us to verifying push piece. Okay, good. So we got further. So it still says I don't have enough context to prove what you want because we need a specification for fall. And this can be a little more complicated. Okay, so either we reach the end or the y coordinate has decreased by 1. All right, what doesn't it like about, no. First, okay. So we might have to replace falling position with a measure. Oh, we didn't guarantee it's bounded by 0. So we're gonna have to change that. Which may mean that yeah. So it says, hey, you told me all this great stuff, but I could not prove this. And one of the things notably absent is that the coordinate's always greater than 0. So let's restrict this. Y chord C greater than or equal to 0. In fact, it should be greater than or equal to 1. Right, 1 is the lowest we can get. So now it says, how do I know that you how do I know that you've guaranteed that? Let's just say if if it hits the ground, so this removes a case we need to check and intersects, but we could put a type on intersects that guarantees that if y chord new pause equals 0, or yeah, so this is a little bit redundant, but lifting up here means Liquid Haskell can now access it and hopefully prove that our new position is valid. We may have to fill in the amount. Let's see. So, do we need to tell it? I don't think so. Right, so we put where did we put it? We put that the y chord is greater than or equal to 1. We've successfully checked that. We verified that we could make this stronger. We could say if and only if. Second, no, not. Okay. Doesn't look like that was enough. So it's got all the pieces here. Right, knows for any game board this is true. A stronger condition is true. It knows that A has the type. And it should know that this is, we're in the case where this is false. So this should be true and this should be true. So this says the game board we created has the y coordinate of the b minus 1, and b it says, oh, that's equal to g. So it should all work, and it's not. So I'm wondering if it's this, I'm wondering if it's the auto-generated the auto-generated function or measure is not enough. So what I'm going to try doing is adding a new measure. So from a game board to nat, uh, so falling y. Blank, 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 pause, blank, blank. X, Y, point. Okay, and introduce that as a measure directly on game boards. Oh, I didn't like that at all. How did I do this yesterday? Kind of like that. All right, better. So let's rewrite our termination condition in terms of that. So so those should all still pass. There's logic. So G2. Liquid Haskell needs a better specification parser to say what's wrong. All right, so it didn't actually like these. Can't prove that anymore. Why not? Seems like it should be within its capabilities, but the change to the measure means that it maybe can't figure out the y coordinate here. Let's try that. We'll discard a nice int function. Okay. I think that made it happy. Okay. So we convinced it that when we drop a piece, we won't loop forever. So now we need to build the main loop on top of that. So um, drop all pieces. Okay. All right, so this will move the piece all the way down until it's stuck. We need to do all the bookkeeping. So our next G is so what are we going to update? We're going to so we're going to have to put in a check that this is safe or in the specification. Because we said that's a init, a a natural number. We don't have to adjust the wind. That's been done already. Um, let's write a function to do this. Uh, all right, so new rocks equals the filled from G union with the offset, the translated piece. Okay, so that's that. And the new top rock is does set have minimums? Find min. All right, so all right, so we made a mistake. We should have gone with y first because then the key would be y then x, and instead is x then y, and so the maximum y is scattered in here somewhere. So I'm just going to do the whole thing. Map maximum, not minimum. Do we have to import that? Yeah, so that's less efficient than we would like. Right, we're gonna iterate over every dropped rock because they're in a set and it's ordered, we could do better, but all right. All right, so the new falling position is 2 units away from the last wall. So that is x coordinate 3. and bottom edge is 3 units above the top. So that is +4. So if we start at 0, 1, 2, 3, 4, yep, if once this is done, then 0 is +1, +2, +3, +4. Okay. Okay. So in if num rocks remaining of next G equals 0, then return it as is. Otherwise, drop the next piece. So we're going to have to give this a specification. We're going to say it can only run on a game board that has num rocks remaining G is greater than 0. And we have to specify that our termination condition is that the number of rocks is decreasing. All right, I got a bunch of problems here. Translate falling piece of G. There we go. Oops, up way too far. Falling position. There we go. Map that. Yeah. Couldn't match. Num rocks remaining G. Well, okay, so this is the problem. This is the problem I was trying to fix. Right. Okay, we need to call rocks on that. So this is the problem I was working on in the stream in that maximum file is the type of maximum is not sufficient enough to know that this is greater than or equal to 1. Right? Just because everything in it is greater than or equal to 1, it doesn't know that that's the case. So what we're going to do I mean, we technically we didn't even guarantee this was empty. But what I'm gonna do is we're gonna say the new top rock has to be at least 0, and that should make it happy. But it did not. Why? Because min is greater than 0. Max. Max. There we go. All right, that should help. All right, it can't prove. It says drop all pieces. Oh, that is an infinite loop. This needs to be after drop. Sorry, next G. If we call it on the same one, then yes, we will get an infinite loop. So I really hope that doesn't look like it. All right, so it knows a surprising number of things here, but not the one that we needed most. And it says, hey, you filled it up, you calculated a new top rock. That is an odd thing to know, but sure. It knows the following is greater than or equal to 1, but it threw out the key fact. What if we put the key fact? What if we put it closer? I don't really expect that to work, but felt I had to give it a try. I don't. I think it just doesn't do a very good job of. All right. What I'm going to try is constructing it from scratch. Yeah, I think Liquid Haskell has a problem with the. I don't know if like there's an option to do that. That's a good thing to ask the Liquid Haskell Slack about. Is what the heck is going on there? All right. So the termination checks. It says yes. Reduce the number of rocks remaining. So let us do part one. What's going on here? All right. We got to define our starting position. So I am actually going to. We can do it later if it's not working. 2022 rocks. So why is my indentation screwed up? All right, some bracket. Oh, phooey. That's the brackets in the comments. That wasn't a Liquid Haskell problem. That was an Emacs problem. Um, why is what the heck? All right. Hello, welcome. Welcome back, Epsilon. We're close to, I think, trying it out on part one here. So I'm using a language called Liquid Haskell, It is Haskell, but with type specifications. So you can say additional things about the normal Haskell types. So, for example, in today's puzzle, I can say the number of rocks remaining has to be a natural number that is greater than or equal to 0, and the wind and the next piece have to be infinite loops because I'm going to use cycle to create them. The falling position has to be greater than or equal to 1. If it's 0, that's in the ground. So next piece is piece order. Here's my piece definitions. All right. I was worried about this. I did not come up with a good utility function for creating the initial state. That it's all buried in here. So we actually have to put the first rock right. I have to put the first rock already on the board. So falling position, that is that is 3, 4. Filled is the empty set, and top rock equals 0. Right, seriously, what is going on? All right, I'll figure it out eventually. Yeah. All right, so we're gonna drop all the pieces. I don't know if I can write this code without my auto indentation working. Something about this function has made Emacs very unhappy with me. I don't see what it is. All right, so we're gonna print the top rock. All right, I'm gonna have to run the compiler to figure out what's going on here. All pieces start. So does that satisfy all the conditions? Should. This is fine. These are both infinite lists. Oh, length of input less than 1. There we go. My infinite list things are not working. Oh, I need to check that the input is non-empty. Uh, so that's one of the things Liquid Haskell is checking is I gave it a specification type for cycle that says this only works on non-empty lists. I checked that the list of input was not empty, but not that the line itself was not empty. So or length head input less than 1. All right, let's try that. Uh, dang it. This is a stupid place to be getting stuck. But this is what Liquid Haskell's trying to do is ensure I don't call a function that will fail with a panic, because as taking head of an empty list or cycling from an empty list. All right. Inferred type len is greater than or equal to. No, but I just checked it. Uh, Seriously, what the hell? Is it my comment here? No. I have never had this problem with Emacs giving up. Maybe I need to reload the file. Okay, looks good. All right, let's go for broke on the. All right, that's not going for broke. We're just going to try the example. All right, 1 1, not even close. Wow. All right, let's build some debugging facilities then. So so one of the things we can do is rather than returning the final state, we can return all the states. All right, so next G colon. Okay, and then what's the Haskell function for? All right, I'm just going to take the well, we can't print it out as is. We're going to have to do a show. Let's just look at the first one. Okay, so G so game board to string. So what's this going to look like? We're going to say not very interesting. Let's also show we can't really print the set, but we can show the falling position. We did implement that, yes. And we could write the nice version of this, but for now, I'm just gonna dump this out as a list. You see, oh, thank you. I will correct that right away. So otherwise, I'll forget about it. Thank you for that. Yes. CLH. Thanks. All right. All right, so let's make sure. Let's just do this. All right, and what we're gonna do, let's do the first couple. So map. Will map work in the? All right. Put line of unlines of map show piece show game of take 5. All right, so that'll work without having to convince, I think. Oop, I need to do this. This needs to be a list, and I need to specify set.toList. All right, well, those are not falling at all. I can tell that that is the problem. So let's look at our fall. So, so we have a specification here that says either it bars right away, either it returns false. Did I swap true and false? Or we move down by one step, and we're not moving down by one step. So that means our condition here has to be wrong. So assuming add works, the most likely culprit is intersects. So let's run this in GHCI. Oh crud, we're gonna have to create a game piece, a game board. All right, we're gonna have to. We can make this work. All right, so can we is our translate working? Okay, so translate. Piece 1 by oh, we didn't provide a way of printing pieces. Crud. All right. So yeah, I mean that looks right, or else we wouldn't have ever gotten to. We wouldn't be hanging up in midair there. All right. So let's look at right. So the restrictions I don't think should apply here. Empty falling position. Empty and top arc 0. Piece set empty. All right. Great. So we got our game board. Let's call intersects. So does intersects G so the piece is piece 1 and the translated position is 3 comma 4, right? Yeah. All right. So it's returning false. Fall. So fall should be oh, maybe we're getting push piece wrong. So let's do let's set up a game that actually has wind. So this is that. So what does push piece G2 look like? Okay, it moved over. Good. So what is fall of push piece? All right. So there's our bug. It should have at least shifted over. So we call push piece. We get an updated one. Fall. Okay, we got moved over. Then we went down. I f- so we should iterate. Okay, let's try that. Drop piece. Okay. Acceptance. Why? Oh, all right. Right. So that seems sensible. Okay. So we probably did not update the piece. Probably didn't put the piece in the right place. Yeah. There we go. So we need to use the position of the rock after it has fallen. And for consistency, I don't want to mess with that because that's our termination condition. Top rock. Okay. That looks better. Let's try that out. Okay. Good. That fell to the bottom. Afterwards, we got rocks at, let's see, this is 1 1 2 2 3 3, yes, 3 4 3 4 4 1 2 3. That's not good. Okay, I might not have to write that thing to print. So 4 1 4 2 4 3 4 2 3. This is 3 though. So it looks like it's not been pushed right. Three, 1 4 1 5. Yeah, that's right. Is the position correct? Position should be 3, 1, 2, 3, 4, 5. Yeah, that agrees. Hmm. I'm looking at this again because this is where I screwed up. So we want to use this function. All right. Okay, we can simulate this. Why is it recompiling everything? G equals game of right, left, right, left, right. Left, right, left, right. What's next? Other order. Piece. The falling piece is piece 2. The falling position is one, two, three, 4, comma 1, 2, 3, 4. Oh no, 4, 1, 2, 3, 3, comma 1, 2, 3, 4, 5, 3, comma 5. And then the filled is can I copy this? Not quite. That's pairs. So we have to edit it. If I'd been thinking ahead, maybe I would have put some of these as variables so they'd be available in the interactive session. And then the top rock should now be 1. Okay. Okay, so if we drop that piece, then it says its position is 1, 2, 3, comma 2. Yes, that is correct. So why Or 1, 2, 3. I think I just counted wrong. Counting is hard. Translate falling piece of G with falling position of Okay, I guess that was right. I should have written the print statement so I was not screw this up. Let's all right. What I need is to get the very last list element in the list array. I'm hoping there's a last. Okay. Um, is Liquid Haskell going to yell at me about using last? It is. All right. All right. No, I'm going to do this another way. This is silly. Uh, we can just guarantee that the list has at least one element because both cases do. There we go. That's a better solution. All right. Seems closer. 3068. Yikes. All right. So that suggests an off by one error. What happens if we do that? We drop an additional rock. Don't have a great deal of confidence in this, but okay. So why is that right, or is it wrong? So this is rock number 2022. We go down to rock 1. We report rock 1. Yeah, we report after rock 1. All right. So let's try it on the real one. That's messy. I don't like that. Like I said before, I really should have had a better way of setting this up, but it's at least plausibly correct now. Let's try it out. That's the right answer. Hurrah! Really? Really? All right. I feel the need. All right. This is a ridiculous number. And so this suggests we need to cheat. So the if the top row is ever a solid line, then no. Okay, so yeah, and we're not gonna run through 10. I don't even know how many that is. So we gotta look at our output and figure out when it cycles. So it's going to be some multiple of the least common multiple of, sorry, it's going to be a multiple of both the 5, the number of shapes, and the length of our input. So if at any of those multiples we have the same state, then we'll know that it must repeat in the next iteration. So we need to find that uh, that window at the top. So how would we recognize that? Because it might not be at the start of our cycle. How long is our input? All right, let's start working. Let's start getting the code to work on this. So really, that's all you wanted to put else? I don't think it goes there. Um, um, we may want to. 1091, nice, nice prime number. All right, so all right, so we're looking for cycle that's 1,000. We're looking for two two game states that are the same, that are separated by the cycle length. Am I overthinking that? Is there just if we ever got a flat thing, then we'd be good. So maybe I should check for that first. It's a good thing. Good thing we. Good thing we wrote our function. Changed our function to return all the states. All right, so we're going to. All right, we're gonna do this in easy mode. We're gonna look for a solid row on the top row. So take um, all right, let's define our predicate. Again, I'm doing this on the hope that it's easy. If it's not, we're gonna have to work harder. Um, uh, filled. All right, the top rock G. Uh, so we're going to say is All right, it can't be 0, 2, 3. How wide is it again? Is it 7 or 8? 3, 4, 6, 7. I suspect we're going to have to convert this to a 7-bit number and look for the repeat that way. But let's try the easy. As I said, let's try the easy one first. Is flat. Um. Well, presumably you rated because you already solved this. Come on, what is it? What do they call it? Game board. Anybody want to give me a hint? Is this approach going to work, or do I need to plan on the hard version? This should be a. Okay. Well, we should fix our set. I was already slow for 2000. So, what we're gonna do is we're gonna swap the order of y coordinates and x coordinates. It's going to create all sorts of problems for us. Because we did everything under that assumption. Can I, no, nope, nope, that's wrong. We definitely don't want to go through and change all those. What we're going to do is define the order on the set. Um, so when did we do this before? No. What was the day? There we go. Day 13, we had this packet pair. We just sort, so Oh, I use sort by. Right. So we're going to use the default comparison pairs, but we're going to swap the order. And so that should let us replace this map where we iterate over every rock we've dropped with well, data. Oh no, package goes down, I'm in real trouble. Oh, no, there we go. Find min. So we actually want find max. Set dot find max of new rocks. Okay, so we're creating a big collection, but at least we're not iterating it on every piece drop. I feel I'm really counting on lazy execution, not actually doing all this. But what we can do is actually do cycle length, just to be sure. All right, let's double check that we didn't break anything. Oh, we didn't do the magic incantation. It says, yes, you are now blessed as a member of the type class. That is quite an error message. All right, 3068, good. Wow, part 2 ran quickly too. Oh, because we had a short cycle. Um, yeah. All right, we didn't get lucky. So, um, how? All right. So the thing I'm worried about, and maybe I shouldn't be, is if we find a position that looks the same, how can we be sure it's actually the same? Like something could, if it's not completely filled, then something could sneak down into it later. So I think, let's see, am I being wrong by concentrating on the board state? Is there another way to just sec here? Get my get my thinking octopus out. Although I think thinking octopus is unhappy right now. Um, would 3 rows be enough? If they were the right 3 rows, certainly. All right. So let's so if we only use the top 7 bits, then there's guaranteed to be a repetition. How big is Dang it, I think I lost the cycle count. It was something like 1019. Oops. No, it was more like 50,000, I thought. Oh, there we go. 1092. Yeah, it's counting the new line. Yes. Um, so how do we tell when something has been filled, something has been created that behaves the exact same way? Um, I mean, we can detect a cycle if we can decide that a finite amount of state is enough to detect it. And I'm just wondering how much is a finite amount of state. Because it seems like 7 bits is not enough. We get lots and lots of repetitions, but they wouldn't be. Not necessarily. I mean, they could be all different. All right, let's look for top row. Okay. Uh, let's write some conversion function. All right. Place value. All right. So if set dot member coordinate of field G, then place value else 0. I'm too tired to write this for real. I'm just faking it. Okay. All right, so that gives us a representation of just the top row. So given a list of game boards and an int, uh, The cycle length are going to return. All right, so we're gonna iterate through these all. They've got an index ready, which is the number of rocks remaining. Hopefully a million will be enough. Um, we're gonna need a map. No, we're not going to need a map. We're going to need zip. So we're going to take all right, we're looking for two positions that are exactly our cycle length apart. That have this. This seems too simple. No, that are a multiple of our cycle length apart. Uh, it's too. I'm too. It's too late for me to think clearly. I'm thinking: is the cycle length gonna be? Could it be greater than the cycle length once it gets established? Yes, because we could have a different states, starting states, right? We could have so it's no assuming the just the line is sufficient, which it isn't, but it's sort of the number of distinct top layers times the cycle length could be our maximum size. So I was going to match up things at the cycle length boundary, but now I'm wondering if that's not good enough either. If we need to be looking at all the multiples of the cycle length. Well, sorry, this is not very entertaining. Uh, Again, I'm not proud. I'm willing to take a hint from any of the raiders who showed up. If you saw this solved before, uh, try on increasing cycle lengths, I guess. All right, let's try this. All right, so that pairs up everything with something an identical position. All right, and what do I? Okay. Oh, we don't really want to print these out, though. All right. All right. If all right, let's see if we can find one. Maybe we'd be better off using the example with its shorter cycle, but I think that shows. Okay, duplicates. Yeah, I think that that example shows we have to have a code that works even for a short cycle. I'm worried that length dupes unlazies the list. So hey, welcome. How long did this one take you? That's pretty good. Still puzzling part two. I am puzzling it too. Uh, yeah, I am trying that too. Um, but I'm unsure about what constitutes a sufficient repeat and how hard do we have to look for it. So this experiment is looking for two things that so I figured that the product of the number of pieces 5 and the cycle we're looking for has length 5 times our input size, but it could be a multiple of that. So somehow I think I'm going to end up looking for all multiples if, again, this is not just the easy case. And of course, liquid Haskell is not playing along. It says you didn't prove that length is empty. Yeah, that's what I'm worried about. Is we got that vertical piece, and we all know from playing Tetris how well the vertical pieces just slide in. So I did not find, a complete row clear where we'd found everything. I'm going to tell Liquid Haskell I don't care about screwing up here. So yeah, it might be that 3 rows would be enough. 2. I forgot the 2 there. Yeah, it's a billion is just I mean you'd need to, I guess, a gigabyte, a giga. It seems like you'd need to. Hey, yeah, you'd need to truncate it somehow. Uh, all right. So this is bogus. I found a top row that is empty, which should not be the case. Oh yeah, it found the end of the list. All right. So can we look for, how do we look for duplicates of, so this is cute, clever, cute Haskell code. Oh, that's a good thought. Uh, I mean, you can create an overhang and then slide in under the overhang, though. There's yeah, there's got to be some reasonable thing we can say about when will a piece not make it through any longer. Um, so what I want to do is create the sequence n, 2n, 3n, 4n, 5n, and interleave all those searches. I guess I don't have to interleave them. I can, yeah. So when I searched, I got to the end. Oh no, I got to the beginning. All right. No, no. This might work after all. Yeah, I'd imagine it is. Is it fast enough, though? I think my find duplicates is wrong. Why is it telling me that? Those aren't the end. This is very. It's a very round number, which makes me very suspicious that it's some artifact. Yeah. It's just finding the. It's just finding. That's the first one, though. Okay, well, not impossible then. Not impossible, just significantly difficult. All right. What this says is it found a repetition 200 rocks later. Be ready for next Christmas. Um, Okay, so if we assume, I kind of want to take a look at these. I should have written the code to print these out, because otherwise I'm just not gonna be comfortable with it. All right. All right, we get to use my new favorite function, which is take chunks. All right, unlines of take chunks 7 of all right, if set dot member c um, member c filled okay, so ASCII is going to be XY for Y in range uh, X1 to 7. Print. All right, let's see what the top of that looks like. I wonder whether I still got a problem. Not take chunks. Chunks of. Don't know where that spare int came from. Well, that's good. I mean, you could imagine a variation of this in which, well, but you deleted everything below. What is going on here? Yeah, I mean, you're only looking at a constant sized frontier. If you delete everything below, um, yeah, it's probably. Yeah, I see the similarity here. I didn't my print method doesn't work. Is this because I'm printing it in the wrong order? It's not automatically on my liquid Haskell my Haskell knowledge is not showing. Is my lack of Haskell knowledge is showing here. So if I do 7 down to 5, yeah, that's all right. That's the problem. Okay, can fix this. Top row G minus Y. Y equals 0, 2. top 0 minus. Oh, phooey. That's the wrong thing entirely. I want top rock. I shouldn't have called those things the same. Yeah, so that's what I'm trying to get to too, is I was looking at just repeats. Right. So this is the first repeat it found is this is 200 away from so after 200, which is just one cycle, uh it's back in its initial position here. But does that repeat at 400? On the first yes, this is the same top row as the very first rock that was dropped. At the I something's wrong though. But yeah, so 3141561. 3, 4, 5, 6. But my count is bogus. I'm given that. Oh, because I messed the coordinates up. Yeah, that's better. But it's surprising that there's no prelude. Um, let's see how far along this continues. So let's I'm too old to. I'm too not too old. I'm too tired to deal with this monad shit. Uh, I want to. I want to iter over list and print each one. So can I just? I don't think I can just use map for this though, because that returns a list of units, and I need a. I just need to return a single unit. Sequence. All right, sequence map. Let's try that. I just want to run the function several times in order. All right. Damn it. All right. I'm gonna have to. I see. Okay. Well, those look identical. Uh, those two are not. Seven. It's interesting. There's a gap there. Okay, so if it had really repeated here, then the next five would all be identical, and they're not. So what we actually want to find, we want to find a sequence of we want to find a sequence of states that all map back to the same. Hmm. Okay, what will this look like when we found it? What it'll look like is every block gets added at the same offset as it did some number of cycles ago. And once we catch up with where we were before, then we'll be fine. So that's an upper bound, right? We have to remember the window. I wish I could draw this, but I'm gonna have to sleep on it. It's been 4 hours. Uh, Not gonna solve it tonight. Need to figure out how we do cycle detection in a way that's robust. And this first one isn't easy because the looking at the top row or even the top 4 rows, like the top 4 rows were identical here. The top 5 rows were identical here, but then 999, 99996 is missing. That wasn't the same. And the later ones aren't the same. So uh, we need a more we need a longer window longer even than 5, and that means we have to do it in some different way. All right. Have a good weekend. I don't know when I will find time to finish this. This might be where I finally fall off. All right. Good night.